So we know the idea of an algorithm. An algorithm is a written expression of software logic that's not expressed in any particular code. So this language here probably is not any programming language at all. Print, enter length, input length, print, enter width, input width. Area is equal to length times width. Print, the area is, so this is what's known as pseudocode. Doesn't exactly match the pseudocode that you may have learned in 113, but it's pseudocode, obviously. Now we could turn this into Java. But if we eyeball it first before we rush ahead and load up NetBeans, this is a variable. A variable is something that contains a value. More technically, it is something that has a name, a type, a value, and a memory address. It's an alias for a memory address. So the name of that one is length. The input statement is supposed to fill it somehow. And then the name of that variable is width. The input statement is supposed to fill that one. And then if we change that one to an equal sign, it would look a lot more familiar. This expression, length times width, would get evaluated and stored in that variable so that we could then print it out. Now in this language, unlike Python, you have to declare all your variables first before you use them. So that would look something like this. I'm going to skip the print, but I'm going to need a length variable, and I would have to decide what type it's going to be. Whole numbers sound fun, so I'm going to do that. Int length, you don't necessarily have to type this because we're going to be putting it into NetBeans soon. Int width, and int area. Now we have our three variables. In this language, you have to declare your variables before you can use them. In Java, we would be enclosing chunks of code in semicolons, excuse me, it's not a semicolon, in curly braces. Tabbing is a nice thing, but not strictly necessary in this language, unlike Python. Now that we've declared those variables, we can do the rest of this stuff. As we've already seen, to do a print, you do system.out.print or system.out.println. So that would be our print statement. What we haven't seen yet is an input statement. It sure would be nice if it was as easy as Python, where we could just do input. But unfortunately, it's not. It's because it involves a class. We need to create an object before we can use an input statement. The class is called scanner. So we're going to have to create a scanner before we can use it. I'm going to go ahead and tack this on here. Why don't I do this in NetBeans, though? So, launch NetBeans. Oh, Daniel, did you get NetBeans working?
I'm afraid not.
Ugh.
If I take your I'll talk more about it after class.
Okay, all right. I won't have much time to talk about it after class unless we end a little bit early. We may wind up talking about it. Well, tomorrow's going to be hard. Yeah, I'll try to end a little bit early so that we can talk about it. All right, load up. NetBeans cannot locate. Do you wish to use the default version? Yeah, sure, why not?
You want us to load it up too?
Sure, why not? This is the part where we all type along together, if you choose to do so.
We have to download it, or should it already be on the machine?
NetBeans should already be on your machine, so just go to search, type in NetBeans, it should pop up. You can right click on it and pin it wherever you want. Find it?
It's launch, I think so.
Okay, good deal. Alright, I'm going to create a new project. May not be loaded for everybody, but you'll be able to catch up. File, new project. It's a Java application. My instinct is to always type a project name up in filter, but that's not where you do it. It's after you click the next button. I'm going to give it a fancy project name, Lecture C. If you get an error, pick a new folder. But I think it's only Visual Studio that's giving people that error, not NetBeans. So I'm not going to click Browse and store somewhere else. Click Finish. It creates our main class for us. At some point, we'll talk about what a package is, and then I'll explain why I want you to remove that package statement after that point. I'm going to remove all these comments, kind of clutter it up, but I am going to put my own comment up there, which is my name and the date, chapter 2. Now we're actually skipping ahead because this chapter may not even introduce the idea of doing the input statements. Maybe they wait until chapter 3, but I'm in a hurry. We've talked about the algorithm. I actually want to implement it. All right, so I like listing all my variables up at the top. You don't have to do that. You can intermix them with the code, and there are times that I'll do that as well. There's no hard and fast rule. You can just pick one or the other or do both. So I already had that going. I needed a length, a width, and an area. I arbitrarily chose them to make ints, but there's a consequence to that. The consequence is that the user will not be able to enter floating point numbers, decimals. So I really should have made them floats. I'll make that change in my notes. I don't really have to because I'm going to wind up including the code, but I'm going to go over here and make 3 floats. Length, comma, width, comma, area. I declared 3 variables on one line. That's legal. Or I could do float length, semicolon, float width, semicolon, float area. So my print statement, system.out.println, and I'm going to display a message. What's my message? Enter a length. Okay. So system.out.println, enter a length. Now I need to do some input. I wish it was as easy as just saying x is equal to input, something like that, but we have to create a scanner object from the scanner class. And to do that, we need to include the scanner library in order to get that. Sounds complicated, but NetBeans makes it easy. I'll show you what I mean. Now I should probably create this above my, just like the other variables, an object is a variable as well. So above my system.out.println, I'm going to go ahead and create my scanner object as well. It's a scanner, and that has to be exact with a capital S. And then I'm going to call it, I don't know, IN. You can call it anything. This is the variable name. That's the class name. See, we're already using classes before we've even talked about what variables are. But in Java, absolutely everything is pretty much a class. So we have to bang up our heads against that idea and then start talking about them. So scanner IN is equal to new scanner, parentheses, in parentheses, system.in. Has to be, why did I put quotes around it? Remove the quotes. Like that. And I'm getting an error message. The reason why is that Java doesn't know what a scanner is. I'm going to have to add an import statement to bring in a library that has a scanner class. I could scroll up there and add import. But we see this cute little error symbol over here? We're going to rely on this crutch. I'm going to click on the error indicator, and I'm going to add an import. Now, if you don't see add import, if the only options you see are create class, don't click create class until you absolutely know what you're doing. If you don't see add import, it means that you misspelled it. Like what if I put 3 N's rather than a 2? Same error, but if I click on that, oh, it still thinks it's a scanner. But what if it was something completely different? All right. And then I click over here, add import. It's because I got it correct over here. Yeah. But if I went over here, import is no longer there. So let me correct my spelling errors. Add import java.util.scanner. The scanner class is stored in the java.util package. Once I do that, the error goes away. If I scroll up, well, I don't even need to scroll up. Here it is. Import java.util.scanner. All well and good. The reason we did that is because we're going to use our scanner to read a variable in. So length is equal to in.next float, parentheses in parentheses, semicolon. Now I'm surprised that the editor wasn't giving me any choices about that. I'm going to try it again. In dot, and here's what it does. It pops up the IntelliSense, the helper. I'm going to know that it's next, so I'm going to type in an NEX. Now you ought to be able to scroll up and down to pick the one that you want. Just demonstrating that. Okay, so we've got the length. We need to do the same thing to get the width. If I was programming this myself, I would just copy and paste and make a few changes, but I'm going to tough it out and type in system.out.println, enter a width, end quote, in parentheses. And then width is equal to the same command, in.nextFloat, parentheses in parentheses. Our algorithm showed us the formula for calculating area. The area is just length times width. So, area is equal to length times width, semicolon. Notice that we're ending every single line in a semicolon, but don't think that that means you do have to end every single line. Notice that there's no semicolon there, and there's no semicolon there. Pretty much, you never put a semicolon before or immediately after a curly brace. That would be a syntax error. So with that, it might compile with that one. I like to brace out my code in this format. I like to put it on a line by itself, but then it makes it more inviting to put a semicolon there. It's still an error because this is still directly in front of the brace. You'll get real familiar with where to put your semicolons and where not. I do like to brace my code like that, to where I have the curly brace on the next line. Now you can configure NetBeans to do that automatically for you. If you want to, you can do it under Tools. Tools, Options, Editor, Formatting. So I went to Options, Tools, Options, Editor, Formatting, and then the language was Java, and I can go to Braces and say that I want all my braces to appear on a new line. After a class declaration, after a method declaration, and for everything else. Now that's the way I like it. But the programmers at Oracle and a whole bunch of other people out in the wild like to put the braces on the same line, not on the next line. That's the default for NetBeans. It's just your choice. I am going to do it that way. Alrighty. We have calculated the area. Time to print it out. System.out.println. The area is space, because I'd like a space between the word is and my value that I'm about to print. After the quote, plus sign. I know in Python you use commas to separate everything. I'm going to go to the next line, but I don't recommend that you don't have to do it because you're using a smaller font than I am. Area, in parentheses, in semicolon. In this language, it's legal to break your stuff up against multiple lines. And in this language, tabs don't matter. They just make it a lot more readable. I could remove all the tabs and it would still work. It's known as white space, and in this language, it doesn't care about the white space, unlike Python. The same is true of C++ and C#. If you've taken either one of those languages, you're already real familiar with the idea of placing braces. Okay, so there's my code. I wonder if it's going to work. I'm going to hit the hammer and broom, which cleans and rebuild the project. Clean means it deletes any intermediate files. Don't have to strictly do that. You can usually just hit the green arrow. But if your code mysteriously stops working, and you can't figure out why it's running the old version over and over, even though you're making changes, then go ahead and try clean and rebuild. If it still seems to be running the old version, I'd recommend closing NetBeans and opening it back up. All right, so I'm going to run it by hitting the green arrow. There we go. Enter a length, 100. Enter a width, 200. And the area is 20,000. That looks good. I'm going to show you an alternate form of the print statement. There is just print, which does not go to the next line. So I'm going to take the ln's out of those two statements. And then when I run it, the cursor will be right there on the same. I have to still click over it, right? And I can type in 100 and 200 right there. Now that looks ugly, right? Because I didn't put a space there. So if I'm going to use print, I would probably want to put spaces after, or a colon or something to indicate that that's where the prompt began. All right, that's one thing you can do. Here's another thing you can do. We're getting way ahead of the book here, but we're all smart enough to handle it. I'm going to comment this out, and I'm going to change it to something. System.out.printf. That stands for formatted print. The area is %f units, \n. All right, I added a whole bunch of stuff here. And then after the end quote, and that's the backslash, by the way, above the enter key, I'm going to put the name of the variable, and then I'm going to put the semicolon. So what does this mean? You may have seen this in another programming language. This is a formatted print. This is a placeholder that gets filled in with this variable. In this language, you have to specify the type of data that's coming in here. And since this is a float, we use %f. If it was a double, we'd also use a %f, oddly enough. If it's an integer, do we use %i? No, we use %d. Why didn't they make it just the first letter? I don't know. Anyways, dates back to the C programming language in 1970. Who knows if they were on drugs or not. So here we go. I'm going to run it. And when I do, enter a length, 5, enter a width, 6. And it says the area is 30 point, and then it displays a whole bunch of decimal points. 6 to be precise. What if I don't think it needs that many decimal points? I can make this say %.2. That's going to place 2 digits after the decimal. And you need to space it out exactly like that. And you can't make it %f.2. It has to be %.2f. The % is the placeholder. The f indicates the data type that's being printed out. And the .2 is a formatting specification. There's a lot of other things you can do besides just putting a dot followed by a number in there. But that's going to make our output look a little bit prettier. Enter a length, 5. Enter a width, 7. Here we go. And the area is 35.00 units. All right. Why did I show you this formatted print statement? Just because I think it's nice to be able to do that. Like, what if you're going to print out a dollar amount? It's nice to be able to put, like, pretend this units was $1. I'm going to undo this change, but I could put a $sign there. And then when it printed it out, it's going to look like money. Right? $20. If I didn't have that, it would just print 20.0. And yeah, I could probably get a $sign in front of it if I was doing it like this. But if I put the $sign there, yeah, it might work, but it won't necessarily be formatted to 2 decimal places. So, wanted you to get the idea of the formatted print. Do you have to start using it immediately? No, but I'm going to wind up using it again and again in class. So along with next float, you have others. You have next int. Int is expecting an integer, and you'll actually get an error if you call next int. And the user types in a floating point number, something with a decimal. And then there's also next without any qualifiers brings in a string. I think I'll actually make a couple of comments to that effect. Next returns a string. Next int returns an int. Next double returns a double. Yeah, we get the idea. Next float returns a float. Next long returns a long. Have we talked about all these types yet? No, I don't believe we have. But ints are whole numbers. Longs are whole numbers. Floats and doubles are floating point. A double is a double wide float, so it can hold a much larger value. A long is a double wide int, so it can also hold a larger value. An int is limited to a maximum value of about 2 billion. And so a long has twice as many bits, it can hold a much larger value. You know, the United States debt is in the trillions, it's not going to fit into 2 billion. So if you're writing some program to display the debt, you wouldn't be declaring your variables as ints. You'd be declaring them as longs as one of the floating point types. I recommend that as a matter of course, go ahead and declare your whole numbers as ints and your floating point numbers as doubles. Don't bother with the float type. Now, if your number is going to be really, really big, it's going to be bigger than 2 billion, then yeah, go ahead, and it's a whole number, go ahead and use long. I'll mention that again when we talk about the specific data types. So the print statement. We'll skip that. The input statement, the assignment statement. We're not learning pseudocode in this class. The if statement. Much better. Now in pseudocode, it's just if, and then they're showing this weird little syntax. The thing within the angle braces are the stuff that you fill in, and that's not our Java syntax. This chapter is just in love with pseudocode instead of jumping straight into Java. But we are awesome. We're going to skip ahead and actually learn how to write the if statement. So underneath my printf statement, or maybe even right in front of it, I'm going to put an if. If area equals 0, and it's 2 equals, not 1, curly brace, then I'm going to tab over that system.out.printf. Then I'm going to put a close curly brace. That's dumb. I meant to make it say area not equal to 0. So, not equal, the way I do that is I go and I put an exclamation mark instead of a double equal. There, like that. So I made a change to that line, and I apologize for that mistake. If area not equals 0, then print that stuff out. But if it is equal to 0, I'm going to use an else to handle that case. Else, open curly brace, system.out.println, weird. It has no area. Now, do we need the curly braces here in this case? No. If you only have one line of code after an if or in a loop or something like that, you can do without the curly braces. I went ahead and showed them because we might have wanted to put several print statements in a row, but we could do without them. There's absolutely nothing wrong with putting too many curly braces in. Well, I mean, superfluous curly braces. So now when I run it, if I type in 0 as either my length or my width, excuse me, it's going to say weird, it has no area. So we have our decision statement. The clause is evaluated. If it evaluates to a true, it goes ahead and executes that. Otherwise, it executes that. You don't have to have an else clause. You can chain if statements together if you want. In Python, we had elif, standing for else if. In this language, we have else. If. So if I wanted to, I could put else if, and I could put some other case there, and I could do another block of code, else if, and I could have another case, I'm gonna delete all this stuff because I haven't come up with what I would put there.